Hello. We'll continue with the chapter General Plane Motion, Instantaneous Center of Rotation. We are studying velocity analysis of bodies which are in general plane motion. Read this problem. In the mechanism shown in figure, at the instant, rod AB has clockwise angular velocity 2 radians per second. Determine angular velocity of rod BC and velocity of the slider at C. Rod AB has clockwise angular velocity 2 radians per second. Rod BC is connected to rod AB and rod BC is also connected to a slider at C. This slider can slide in this horizontal slot. So this is the first problem we are solving, in which there are 3 moving bodies involved. Which are the 3 moving bodies? Rod AB, rod BC and the slider. This is the first problem we are solving, in which there are 2 rotating bodies are involved. Which are the 2 rotating bodies here? A rod AB and a rod BC. But again, this is the problem which is very much similar to the problems which we have solved up till now. What is the similarity with all other problems we have solved? In this mechanism again, there is only one body in general plane motion. Watch carefully. Rod AB is connected to the floor or ground, to external stationary surface, by a pin. Such a pin is external pin or hinge support. So it is clear in this diagram that rod AB has fixed center of rotation. Now during the motion, rod BC also moves. Rod BC moves, it's both the ends B and C move. Now watch here, B is a pin joint, C is a pin joint and also A is pin joint. But A is external pin or pin support or hinge support. B is called internal hinge. What do you mean by internal hinge? It is pin joint where members of a system are connected to each other. At point B, rod AB and rod BC are connected. B is internal hinge. Similarly, C is internal hinge where rod BC and the slider are connected. So there are 3 pin joints A, B and C. But A is fixed center of rotation. Rod BC does not have fixed center of rotation. Now to make you visualize the motion, rod AB has fixed center of rotation. So rod BC is in rotation also, but its center of rotation is not fixed. So rod BC has instantaneous center of rotation. So how this problem is similar to the earlier problem I said? In this problem also there is only one body in general plane motion. Okay, during the motion, at particular instant, that is when rod AB makes 45 degrees with horizontal, in this position you are asked to find angular velocity of rod BC and velocity of slider at C. Okay, now let's compare this problem with earlier solved problem. In this mechanism, velocity direction of end A and velocity direction of end B, velocities of 2 points on rod AB, we were knowing. Just by drawing perpendicular to the corresponding velocity vectors, we could identify ICR. In this problem, in that single rod problem also, velocity of B was given and we could identify direction of velocity of A, and knowing direction of velocities of 2 points on the rod, we could identify ICR. Similarly, in this case also, velocity of B is known. Try to understand. In this problem, velocity of end B of rod AB known. Here, velocity of end B of rod AB was given. Similarly, here also we know velocity of B. Because the rod AB rotates about point A, path of point B is circle about point A. So velocity is always tangent to the path. That means perpendicular to radius. So at point B, in this position, velocity vector we can easily draw. It is perpendicular to AB. So this is how we know direction of velocity of B, and of course velocity of C direction also at this instant we know. So this is what I am telling you. Here velocities of 2 points on the body given, here velocity of 2 points on the body given in direction of course, and here also velocity of 2 points on rod BC known in the direction. Not only that, magnitude of VB is also known. You know center of rotation of rod AB, you know angular velocity of rod AB, so you know velocity of each and every point on rod AB. Focus on rod AB now. VB, velocity of end B of rod AB, is length AB into omega AB. Is it something new here? No, it is V equal to R omega. R is distance of B from center of rotation. There are two rotating bodies in this diagram, rod AB and rod BC. So there is a possibility of confusion for some students. But remember, at a time we focus on only one body. So focus on rod AB. So all points including point B on rod AB are rotating about point A, and therefore VB is R into omega, and R is distance of B from center of rotation, nothing but length AB. Now length AB is given 30 centimeters and omega AB is 2 radians per second. So VB is 60 centimeters per second. Rod makes 45 degrees with horizontal, so VB makes 45 degrees with vertical. So direction of velocity known. Have you realized what I said? In this problem we solved, VB was given in magnitude direction. In this problem we solved, VB was given in magnitude direction. Similarly, in this problem also, VB is known in magnitude and direction. So it's not different problem. I can say that indirectly VB is given. So in all this discussion, what you should realize, listen, in mechanisms, path and therefore direction of velocity of an internal hinge can be predicted. So here we could easily predict path of B. Path of B is circle about point C. This slider can slide in this horizontal slot. Similarly, if two rods are connected to each other by a pin, then velocity of the pin is perpendicular to the rod that has fixed center of rotation. So here rod AB and rod BC are connected to each other by a pin. So rod AB and rod BC are connected to each other by a pin. Velocity of an internal hinge is perpendicular to the rod that has a fixed center of rotation. Once again read this statement and we are ready to solve problems on mechanisms. If two rods are connected to each other by a pin, for example here pin B, two rods are connected, then velocity of the pin, that is velocity of this point B, is perpendicular to the rod that has fixed center of rotation. So velocity of B is perpendicular to rod AB because rod AB has fixed center of rotation. You can easily identify fixed center of rotation because it is a hinge support. Now we'll solve this problem the way you should solve in your exam. Watch it. Read the problem in the mechanism shown in the figure. So watch the figure. Yes, it is mechanism. At the instant, rod AB has clockwise angular velocity 2 radians per second. Clockwise angular velocity. Determine angular velocity of rod BC and velocity of slider at C. Angular velocity of rod BC. Yes, angle of rod BC is not given, so we'll have to find out that. This is that dotted line. You should draw only line diagram of the mechanism. So point A, that is fixed center of rotation of rod AB. Rod AB is 30 centimeters long. It makes 45 degrees with horizontal. It is connected to rod BC. B is internal hinge. Rod BC is 70 centimeters long. Angle of inclined members always required. So which triangle has this particular angle? So triangle ABC. So use sine rule as usual. Nothing new you will find now in this problem. And you have found out alpha. Insert that angle alpha, that is angle of rod BC with horizontal. Now insert or show in the diagram velocity vectors including angular velocity. Clockwise angular velocity 2 radians per second, that is given angular velocity of rod AB. Velocity of internal hinge is perpendicular to the rod that has a fixed center of rotation. So velocity of this internal hinge at B is perpendicular to rod AB. So show that velocity. Why downwards? Why not upwards? So clockwise sense of rotation it is. Velocity of C, we know it is a horizontal path for the slider. So point C is a slider. You need not draw that entire block. Velocity of this block is nothing but velocity of point C. Now we are interested in angular velocity of rod BC. We are interested in velocity of one point on rod BC. So basically we are interested in motion of BC. But right now we don't know angular velocity of rod BC. We don't even know velocity of any single point on the body. So such problems, you should start your analysis, velocity analysis, considering that body whose motion is known to you. In the sense, you should start with rod AB because its angular velocity, its center of rotation we know. So consider rod AB. So considering rod AB, what you are going to do? You will find velocity of B. So you should know velocity of at least one point on rod BC, so that you can shift your focus from rod AB to rod BC. So V equal to R omega. So what is distance of B from center of rotation of rod AB? 30 centimeters. That is nothing but length AB. Now put the values. You must be able to focus on one body at a time. Okay. So this is how we have found out VB 60 centimeters per second. And because rod AB makes 45 degrees with horizontal, VB makes 45 degrees with vertical. Of course, 45 degrees with vertical in the sense 45 degrees with horizontal only. Now you are ready to consider rod BC because now you know velocity of end B of rod BC. Now this problem is very much similar to all problems we have solved up till now on rods. Here it is rod BC, 2 points, direction of velocity known. Now one more thing. Now your focus is on rod BC. So forget that there is rod AB. Forget that there is center of rotation of rod AB or angular velocity of rod AB. Forget totally, as if there is only single body in the diagram. You should proceed. So focus on rod BC. You know velocity vectors on this rod BC. So draw perpendicular to VB at point B. Draw perpendicular to VC at point B. And you will get ICR. Known linear velocity, that is VB. Now you know VB. Known linear velocity vector about this ICR suggests direction of rotation. So this is now center of rotation of rod BC. At this instant, rod BC is rotating about this point in anti-clockwise direction. Now distance of C from center of rotation is RC. Distance of B from center of rotation is RB. You will have to find RB and RC. Which triangle has these two sides? So you will able to focus on that triangle now. Now check what information you have in this triangle. So this angle is known. It is 90 minus 17.64. This angle is known 45 degrees. How come? Simple. VB makes 45 with horizontal. So RB makes 45 with vertical. So when you know these two angles, third angle is known. 180 minus these two. So it is the same geometry which we have studied in earlier problem. Now what? Use sine rule and get RB and RC. So RB divided by sine 72.36, 70 divided by sine 45, and RC divided by sine 62.64, and you will get RB and RC. Insert these values in the diagram. RC is 87.92 and RB is 94.34. Now start calculations with known linear velocity. Which is known linear velocity on rod BC? VB. So VB is equal to RB into omega BC. Now RB, distance of B from center of rotation of BC. VB already we know 60 centimeters per second. RB 94.34 and omega BC. So this is how we have found out omega BC. Direction we have already identified. Show it in the diagram. It is anti-clockwise. and then VC is equal to RC into omega BC. Substitute the values. RC is 87.92 and omega BC is 0.636, and you have found out VA. Take care of unit, it's centimeters per second, and VC is rightwards. Now read this problem. In the mechanism shown, at the instant, rod AB has anticlockwise angular velocity, so omega AB anticlockwise, 100 RPM, converted into radians per second. Determine angular velocity of rod BC and velocity of slider at C. You want to know velocity of slider at point C. The problem is very much similar to the earlier problem. In fact, earlier all problems, as I said. Even if there are three bodies in motion, rod AB, rod BC and slider C, there is only one body which is in general plane motion, and that is rod BC. Rod BC has no fixed center of rotation. Rod AB has a fixed center of rotation. Watch here, this hinge support, that suggests you that it is fixed center of rotation, means rod AB is in pure rotation. So immediately it should strike you that velocity of B is perpendicular to rod AB. Do you remember earlier problem what we studied? Velocity of an internal hinge is perpendicular to the rod that has fixed center of rotation. So velocity of point B, we know it is perpendicular to AB, and for anticlockwise rotation it must be upwards. Similarly, velocity of point C is along its path. So we can predict direction of velocity of internal hinges. So simply proceed. Angle of rod BC is required. Angle of inclined members always required. This point is point A. Rod AB 30 centimeters long. At B there is a rod 70 centimeter long. Point C is on inclined path. Just draw line diagram. This path makes angle 20 degrees. That's given with horizontal. Rod BC is 70 centimeter long. You should find angle of rod BC. So check given dimensions. So 50 centimeters. So focus on this right angle triangle. So opposite and hypotenuse, that is sine alpha equal to 50 by 70. And you have found out alpha as 45.58 degrees. So alpha we have found out, or angle of inclined member BC we have found out. Anything new? Of course not. It's similar to all problems we have solved up till now. Let's proceed. Dimensions are in centimeter. Omega AB anti-clockwise 10.47 radians per second, that is 100 RPM into 2 pi divided by 60 angular velocity in radians per second. Velocity of B, check here, velocity of internal hinge is perpendicular to the rod that has fixed center of rotation or that has hinge support. So velocity of B is perpendicular to the rod that has hinge support. And why upwards? Because all points on rod AB, so including point B, are moving in anti-clockwise direction about point A. So VB must suggest you anti-clockwise sense of rotation. Velocity of point C, it is along this path. So here I have shown VC. Velocity of point C is along this path, certainly. There are occasions that students get confused whether it is upwards or downwards. This upward direction is wrong. Deliberately I have shown the wrong direction here, just to make you understand certain things. Suppose you show wrong direction, no problem at all. You will realize that it's wrong and you will be able to correct it afterwards. Now check whether you show VC upwards or downwards. In any case, you are going to draw perpendicular to VC, means perpendicular to this line only. So you will get correct position of ICR whether you show VC upwards or downwards. Now consider rod AB first. Don't immediately start locating ICR of rod BC. The reason is, right now you are not in position to consider rod BC. You don't know velocity of any single point on rod BC. So we should start with rod AB. So consider rod AB. Find velocity of common point on rod AB. Common common point in the sense point B is common for rod AB and rod BC. So common points help you to shift your focus from one body to other body. So that is why considering rod AB, what you are going to do? So of course you are going to find velocity of the common point. So VB is equal to length AB into omega AB. So put the values and you have found out VB 314.1 centimeters per second. Direction we already know, upwards. Now since velocity of one point on rod BC is known, you can consider rod BC. So rod BC, 2 points on the rod are moving in different direction. You are sure that rod is in rotation. So draw perpendicular to VB at point B. Draw perpendicular to VC at point C. Where these perpendiculars intersect, that is center of rotation of rod BC. So known linear velocity vectors, remember VC is unknown. Known linear velocity vector is VB. So trust on known linear velocity vector and identify direction of motion of rod BC. Point B is a point on rod BC. So velocity of B suggests you direction of rotation. But as I told you, now your focus is on rod BC. So forget rod AB. VB about ICR of rod BC suggests you clockwise sense of rotation. And therefore all points on rod BC must suggest you the same direction of rotation. But here we have made mistake. VC suggests you anti-clockwise sense of rotation. But rod BC is rotating in clockwise direction. So what you are going to do is show the correct direction. Okay, let's proceed. Now distance of B from center of rotation is RB. Distance of C from center of rotation is RC. Which triangle has these two sides? You will be able to focus on that triangle. Now what information you have in this triangle? So its longest side 70. This angle we know 24.42 degrees. How come? So listen, focus on this entire line passing through C. So this horizontal line creates 180 degrees angle at C. So 180 degrees minus 20 minus 90 minus 45.58, you will get the remaining angle. So that is 24 point. Remember known angles, focus on the known angles and unknown angle you will be able to find out here. Then what else we know in this triangle? So this angle is known 45.58. Of course, rod BC makes 45.58 degrees with horizontal. So this angle is angle of rod BC with horizontal. So of course 45.58 degrees. So if two angles are known, third angle is also known. 180 minus these two angles. So it is 110 degrees. So this is how we know already in the diagram all the three angles of the required triangle. Now sine rule. RB divided by sine of opposite angle 24.42. 70 divided by sine of opposite angle 110. And RC divided by sine of opposite angle, that is 45.58. And you will get RB and RC. So this is how we have found out RB and RC. Now start calculations with a known linear velocity. When you don't know angular velocity, you should start calculations with known linear velocity. Now listen, once you have found out VB here, you completely forget rod AB. Your focus is on rod BC. So we are not at all confused with this angular velocity or this center of rotation. Okay, so focus is on rod BC. You know velocity of one point on rod BC, that is VB. So VB is equal to RB into omega BC. Now substitute the values. We know RB 30.8. We have found out that. So we have found out omega BC. It is clockwise. Show direction in the answer. And VC is equal to RC into omega BC. So VC is 53.2 into 10. RC is 53.2 into omega BC is 10.2, and we have found out VC. So this problem is also actually single rod problem. Here what I say, that it is a body in general plane motion and velocity of one point on the body, that is Vb, is given, indirectly given. Since B is given as a point on body in pure rotation, Vb we can easily find out. So you must have realized that velocity analysis of a body in general plane motion is very simple. So if such a problem is there in the exam, you will be able to solve easily. Now for practice, just read the solved problems I have given you, and you should not face any difficulty in exam. Thank you.